Alright, so right now we'll be talking about perimeters and areas of similar figures. Alright, now if the scale factor of two similar polygons is a to b, then the ratio of the areas is a squared to b squared. So let's just draw up some pretty simple ones. Alright, let's say I knew that this was 4 centimeters. Let's go a little bit metric today. And the bigger triangle was, let's say, 9 centimeters. Okay. All right. Now the scale factor from the large to the small, okay, is going to be about 9 to 4. Okay. However, usually you want to try to put the smaller number on top. So 4 to 9. Let's go from small to big. Okay. So it's 4 to 9. Alright, so that's the scale factor. Okay, now the perimeter is definitely going to be the same type of ratio, so it's going to be 4 to 9. Okay, and so this would be the perimeter ratio. I forgot to put ratio in there. Okay, and then the area ratio is going to be 4 squared to 9 squared, which is going to be 16 to 81. Okay. Alright, and so that's the really cool thing about knowing similar figures and the perimeters and areas, that you can actually find these really cool relationships to actually find the ratios of, you know, certain measurements or certain areas or certain perimeters. Okay, let's apply it to some problems. Alright, now let's say that the actual area, the actual measurements of a figure looks like this, and I knew that this actual area was about 27 feet squared. Okay, so I knew the area of the first shape. Alright, so what I would first do is I'd actually find the scale factor. Now the scale factor would be 4/10, which is the same as 2/5, so the scale factor would be this. Okay, so the perimeter ratio is 2 to 5, so that means that the area ratio is going to be 4 to 25. Okay, alright, so the first object is 4. If it had a, you know, area 4, this would be 25 as an area, is what that's saying. Okay, now that I know that that ratio is all set up, I can actually set up the ratio from small to large and put 27 on top and put the bigger area on the bottom, because I don't know this area. Okay, but now I can actually use this with properties of similar figures and perimeters and areas to actually find the actual area of this larger rectangle. So I'm going to cross multiply, so 4a equals, let me see, 27 times 25, 675. And then I'm going to divide that by 4, and that should be area is equal to 168.75 square feet. And that's the really cool thing about this, is that I can actually check that out. Now if you wanted to see if that was the actual measurement, you just divide. Okay, and then that's just going to be my measurement right there. And if I wanted to divide these two, the ratio would be pretty unique and all set up. Okay, so I would just go 27, let me see, 27 divided by 168.75. Oops, need to have division. Okay, and that would be 0.16, and if you divide 4 by 25, you should also get the same. So this ratio definitely does check out. So I have to divide the smaller by the bigger, and not the other way. Okay. All right, let's practice some more problems. All right, so let's say your garden produces 3 baskets full of tomatoes. Next year, you want to triple the dimensions of your garden to increase your yield. How many tomatoes can you produce next year? Okay, so this one's kind of hard because it doesn't give any kind of measurements or work any kind of thing. But we do know that the ratio for next year's garden to this year's garden is 3 to 1. Okay, so if that's the ratio of the dimensions, okay, then that means that the square footage is going to be 9 to 1. Okay, so that's actually really kind of cool. So if it is 9 to 1 now, if regularly, with my regular dimension, I was able to produce 3 sets of tomatoes. So if I triple it, now I have 9 times the area, so I have 9 times the amount that I can actually produce. So it's 9 times 3, which is definitely going to be 27 baskets full of tomatoes. Tomatoes. There we go. There we go. Now I spelled it correctly. Now, obviously, with this drought, not going to be able to do that as well without the actual water needed to aerate the land and actually make it producible. Okay. All right. Now, let's say we had to go back and find the ratio of perimeters. Okay. Now, I know that these two are similar shapes and their areas are listed right here. So, if I write out their ratios, so a squared divided by b squared is going to be equal to 25 divided by 70. Okay, so what I'm going to do is I'm going to reduce this one, because guess what? You can reduce it. So this is definitely going to be 5/14. Okay. Alright, so now I'm dealing with this ratio. A squared divided by b squared equals 5 divided by 14. Okay, now if you notice, if I'm trying to find the ratio of the perimeters, all I need to do is get this down to a and b. Well, guess what? You're going to be square rooting both sides. Okay? Alright, so a to b is going to equal to root 5 divided by root 14. Okay? So the ratio of the perimeters is actually going to be root 5 to root 14. Now that's not a nice clean number, but it's the number we got nonetheless that I do want you to actually represent. Okay? Alright, and that's cool because you can actually find the ratio of areas from perimeter, and you can do vice versa. You can find out all kinds of great stuff with just using perimeters and areas of similar figures. Okay? Alright, that's it for dealing with this. I'll talk to you later. Bye.